We learned two things way back in the day. First one's a mixed fraction. A mixed fraction is where you have like a number in front and then a fraction following it. So for instance, if you had something like this, you have a big number and then a fraction following it. That's called a mixed fraction. You have one whole number and a fraction. An improper fraction is when the numerator or the top number is bigger than this bottom number. So for instance, if I had something like 17 over 2, that's called an improper fraction. Realistically, after this year, we rarely ever deal with mixed fractions, and we barely ever even really deal with improper fractions. A little bit, not a lot. Yes, sir.
Then why do we do them?
It's still something that's practical in like life. So for instance, a mixed fraction, even though we never do it in math after this year, or rarely, I shouldn't say never, we rarely ever do it in math. It's something that you would definitely use outside of school. So for instance, if you looked at this number right here, that's a mixed fraction. You would use that for like construction, building something, measuring something. If you did baking, cooking, anything like that, we use mixed fractions. So for instance, if you were like making something and they wanted 2 1/4 cups, right? That's what that would be. It'd be 2 1/4. So it's not something in math that we'll use again in the future after grade 9. Especially in the -1 route, it's very rare. But in real life, we use mixed fractions all the time. What it does is it tells you you have 2 wholes of something and then whatever's following it. So if you measure things, right? If you measure something, that's 2.5 inches, right? That's describing an improper fraction. You have 2 full inches, then you have a half inch. Improper fraction.
That would also be for cooking.
Or mixed fraction. Yeah, cooking too, especially for cooking. When we're going to convert them, so we're going to convert in between improper fractions and mixed fractions and back and forth. Okay, I'll show you my trick to do it. It's not too complex. They have like a little system here that they've built. Like if you want to use that, if that makes sense to you, that's awesome. I'll talk you through what to do. Their steps are MAD, multiply, then add, and then divide. I'll show you what I do. We'll see if it works. So if I wanted to convert, we're just going to skip down to example 5. Number 1, if I wanted to convert that mixed fraction into an improper fraction. Mixed fraction, remember mixed fraction has the number in front. Improper fraction means no number in front. We'll start with 6 1/2. So that's what that is. To convert, you take your whole number, in our case 6, and you're going to multiply it by the bottom number. Yeah. So if you do 6 times 2, you get 12. You're going to take that answer and you're going to add it to the numerator. So I'm going to take 12 plus 1 is 13. And then divide by 2. Number in front, multiply it by the bottom, add it to the top. And that gives you your improper fraction. Yes, sir. Oh, here you go. The reason this works, actually, I'll show you a couple more, and then I'll show you why this works. Okay, because there always has to be a mathematical reason for why something's actually happening. If you look at number 2, we're going to convert that. So you take your big number, my number out front, which is 9. You're going to multiply it by whatever the denominator is, the small number, so 9 times 4. That will give me an answer of 36. And on the top, you do 36 plus 3. 36 plus 3 is 39 over 4. The denominator doesn't change. The bottom number stays the same. Awesome. Number 3, we're going to do it again. So if you want to change that into an improper fraction, you take your 9 wholes, you times it by 7, which is your bottom number. That gives you a total of 63. Then you can add that 63 to your numerator to make it 68 over 7. Number 4, the last one that we're going to do, we're going to talk about why this works. So number 4, you take your front number, which is 3. You times it by your bottom number, which is 10. That gives me 30. I'm going to add that 30 to my top, so 30 plus 1 is 31. If you can just remember that pattern, you're set. Like, you just have to be able to get it right. I'll show you why this works, just because I do think it's important to understand why something works. So for instance, if we look at the first one, it says 6.5. 6 and 1/2. 6 is saying 6 wholes. Okay, I could rewrite 6 wholes as a lot of things. For instance, I could write 6 wholes as 12 over 2. That means 6 wholes, right? 12 divided by 2 is 6. Then I would have 12 out of 2 and 1 over 2. This still is the same number. Right? This is 6 wholes and 1/2. If you had 12 halves plus 1/2, that would give you 13 halves. So that's what we're doing. We're taking our whole and we're writing it as a fraction, like a different fraction. I'll show you another one. I'll do it on the board because I need more space. So if you look at number 5, you would have done 7 times 5 is 35, plus 3, that's 38 over 5.
38.
Yeah. For 6, you would have done 2 times 3, right? Multiply those together to be 6. Add it to the top, that's 8 over 3. For 7, you would have done 9 times 8 is 72. 72 plus 3 is 75. Yeah.
So the denominator always stays the same.
Yep. If you look at 8, we got 5 times 9, 45. 45 plus 2 is 47. If you wanted a decimal for whatever reason, then you could just put that fraction in your calculator, right? So if you wanted to know what 38 divided by 5 was as a decimal, you just go 38 divided by 5, and that'll tell you what it is as a decimal. Remember that fractions just mean divide, right? So that's all it is.
Wait, how come 6 is equal to 3?
Need to leave?
What?
Do you need to leave?
Don't.
How is it working? There we go. Those are all improper fractions where the top number is bigger than the bottom number. Honestly, improper fractions is what you're going to deal with like 99% of the time. So that's kind of normal to get it that way. You could convert the other direction too. You could convert improper fractions into mixed fractions. That's a little bit trickier. So we will practice that. Again, it's not a skill that we overly use going forward, but we will. Yeah, Brax. We'll start with 20 over 3. This question they have up here. And we will talk about converting it. So if you're going to convert that, you have to try to figure out how many wholes you have, like how many entires. So if you look at 20 divided by 3, if you wanted to figure out how many entires you have, you would do 20 divided by 3. And that'll give you a decimal, right? So if you tried it, it would give you 6.6 repeated. What that means is that in your fraction, you have 6 wholes, whatever the first number is. And then you're going to have some remainder. Right? So if you put in your calculator 20 divided by 3, you get 6.6666. That means you have 6 wholes and then some remainder. And that remainder is this decimal. 0.666666. Yes. No. The 6, the first number in the blue, that becomes your number out front, this guy right here. To get your remaining fraction, you could do a couple of things. Okay. I think the best thing you could do is figure out how many you've subtracted away from your 20. Right? So I had 20. I now have 6 wholes taken away. 6 wholes, if you times it by 3, tells you that you took away 18. You took away 18 of those thirds. You then can figure out how many would be left over if you took away 18 from 20. So if I had 20, took away 18, I'd be left with 2/3, right? That's what it'd be. 2 left over, 3 on the bottom still. Going this way is a little bit trickier. Okay, so we'll probably do like 5 or 6 together. We'll start with number 1, 18 divided by 5. If you put 18 divided by 5 in your calculator, you get 3.6. Awesome. I'm going to put it right above it. 3.6. The first number before the decimal, that's going to be your big number. Then you have to figure out how to represent that 0.6, the remainder, the fraction on the side. If you know a way that you've used in the past that works, keep using it. All right, because there is different methods to figure that out. For me, what I would like to do is I would like to imagine what that 3 represents. Right? That 3 represented 3 times 5, which is 15. That was me taking 15 away from my original 18. So if I took away 15, how many would I have left?
3.
Yeah. That's your number that goes out front, 3/5.
And you still keep the same denominator?
Yep, and the denominator stays the same the whole time.
So you take the big number times it by the denominator.
Yeah.
To get the 15.
Mm-hmm.
And then minus it from the top.
Yep.
What? Stop it.
Don't worry about what he said.
No, what just happened?
So what he was saying is that like the denominator, that's the bottom number, will always stay the same. Like it's the same as this number here, which is true. It'll stay the same.
How did we get 15?
How did I get 15? I did 18 divided by 5 to get this.
Okay.
3 is my whole.
Uh-huh.
3 times 5 gives me 15. So that's how I know how many I took away. Right? It is by timesing it by that bottom number.
Oh,
Yeah.
gosh.
So if you try number 2, we're going to do the same process. So if you did 17 divided by 6, you would get 2 point, what's the decimal? 8 3 repeated? The front number, I'm going to do it in green again. Before the decimal, that's your number of wholes that you have.
Wouldn't it be 3 though? You're rounding.
Yeah, but we're not rounding because we're trying to write it as an improper. The decimal, trying to figure out what this 0.83 represents. We want to represent that as a fraction somehow. What you could do is you could figure out how many numbers you just took away, right? I took away 2 times 6. I took 12 away from 17. Leaves me with 5/6. Yes, sir.
When you divide it, you get like when you divide it, or when you have 2.83, if you minus 3 by 8, you get 5. And when you divide it for 3.6 on the other one, if you minus those 3, and you get 3.
Yeah. That should work. Yeah. I think I'm picking up what you're putting down. That method should work. If you look at number 3, we're just going to convert it to a mixed fraction. And we're going to talk about something else you could do with it. So if you looked at 22 divided by 4 and you put that into your calculator, what do you get? 5.5. Yeah, so you have 5.5. The front number is the number of wholes that you have. The remaining number, the fraction, 0.5, You could just write that out if you know what 0.5 is as a fraction, or you could figure out how many you just subtracted away. I just subtracted away 5 times 4. I subtracted 20 away from 22, leaving me with 2 left over. So 2 over 4. Now, if you were to look at that answer, that's not how we would probably write it. Why wouldn't we write it as 5 and then 2 over 4, Nick?
Because 2 out of 4 is 1 over 2.
Right, because we can reduce this guy. Right? We can simplify it.
So whenever there's a half, whenever it's like a half fraction, it always has to be simplified.
Yeah, well, anytime you have any fraction that can simplify, you should simplify it. So for instance, looking at 2 over 4, both those numbers can divide by 2. So I would probably write it as 1 over 2 instead. You should try to get used to simplifying all your answers all the time. So anytime you have a fraction that can be written in lower terms, do that. Awesome. If this method works for you, use it. I'm going to show you one more way that you could try to tackle these questions, which realistically is probably the easier way. But some people really like seeing how this is actually working, hence that first method. Okay, so you need your calculator for this. Okay? Yep. So Joey was asking, could you simplify this fraction to start? Both these divided by 2? You could. You could make it 11 over 2, and then you figure out what that would be, and it would still be 5 wholes, and then 1/2 left over. So that definitely would work. Yes, Kenzie?
Can I have a calculator, please?
Yes, sir.
I bet I'll know.
Okay. Here's how I would do it. If I was to actually do these questions, I would still do the same first step. So 57 over 8, I would put in my calculator, 57 divided by 8, and I would get a decimal. That decimal would be 7.125. Okay, I would still do that exact same first step. And I would still say, okay, that first number, that's my number of wholes. But the way that I figure out my fraction is actually a little bit easier. Okay, the way that I would do it is I would take the decimal now, the 0.125, and I would multiply 0.125 by whatever the bottom number is. So in my calculator, if I put 0.125 and I multiplied it by 8, so not including the 7, right? Just the 0.125, and I hit enter, that will tell me what number goes on the top of my fraction. It happens to be 1. So personally, I think that's the easier way to do it.
Okay, we just do it the way you're teaching.
Yeah, and if you like that subtraction thing, that's cool. You can definitely do it that way. If you like doing the decimal, multiply it by the bottom number, you could definitely do it that way too. Both are legitimate and we get the exact same answer every single time. Yeah. So I did 57 divided by 8, and I got this decimal up here, 7.125. Awesome. 7 is my front number because I have 7 wholes. And then I changed the 0.125 into a fraction by going 0.125 and then timesing by whatever number's on the bottom. In this case, 8. And that will tell me the number that goes on the top. Because that's always kind of the hard part, figuring out what goes on the top. Yep.
I'm done.
Yep. If you look at number 5, using this other method with the decimals, so you go 27 divided by 4, and you get 6. Sorry, I'm trying to erase. You get 6.75. The number in front is your whole number. My fraction, the 0.75, I know will be something over 4. The way I get the top number is by going 0.75 times 4, which is 3. Personally, I think that's the easier way to do it. It's up to you on the way you want to choose to do it. Try number 6, 7, and 8 on your own. Okay, 5, 7, and 8, the answer on the board. Using whatever method you want, you should have got all 3 of those answers. Feel free to write them down if you didn't get those answers. Number 8's the only one that I would change. The reason I would change number 8 is because this fraction right here, 2 over 6, can be reduced. Right? The 2 and the 6 can both divide by 2, meaning that it would become 1 over 3. And we should try to get comfortable with reducing fractions or simplifying them.
Do we round up?
Yeah, so like, for instance, when you're doing this one right here, number 6, like if I put 53 over 9, I get 5.88888888. Yeah, and then if you put 0.888888 times 9, it might tell you it's 7.99999, or it might tell you it's 8.00000. We just call that 8. Yeah, we just round it.
For number 8, I got like 5.3.
Yep.
And it gave me like 1.9999999.
Yeah, so we would just round that to 2. Yeah, and it's just because your calculator doesn't have enough digits to like show it. Cool, that's converting fractions. We're going to quickly do some adding and subtracting of fractions. To add and subtract fractions, the 2 words you use are sum and difference. Sum means adding, difference means subtracting. Does yours format nicer than mine? Okay, to add and subtract fractions, you have to have something called a common denominator. Common means same. Denominator means number on the bottom. So we need to have the same number on the bottom to be able to add and subtract fractions. The way that we do that is by multiplying the tops and the bottoms by the same numbers. So for instance, if I look at A, if I want to get a common denominator, that means I want the same number on the bottom. I need to look at the 2 numbers on the bottom and ask myself, what could they both multiply to become? You multiply by 2 to get 10, right? They both could become 10. The way they both could become 10 is if I just imagine counting by 5s, right? So I had 5, 10, 15, 20, 25, and so on. If I imagine counting by 2s, I have 2, 4, 6, 8, 10, 12, so on and so forth. The first one that they both are 10. Okay, that is your lowest common denominator. That's how you figure out what you want to turn that bottom number into. Then you turn your bottom number by using multiplication. So if I look at the first fraction, I have 5. I want to turn 5 into 10. Then I would multiply by 2. And what I do to the bottom, I do to the top. So this would become 4 over 10. Plus. The second fraction is 1 over 2. I want to make the bottom number 10. I make the bottom number 10 by multiplying. What number should I multiply by? This time, I'm multiplying by 5, right? Because I'm trying to get to 10. So multiply top and bottom by 5. That becomes 5 on the top, 10 on the bottom. It's called getting a common denominator, ideally the lowest common denominator. Once you've done that, you can just add your 2 totals together. So for instance, the blue one is 4/10. The second one is 5/10. If you're picturing pieces of pizza, if you have 4/10 piece of pizza plus 5/10 piece of pizza, you have 9/10. Right? All you do is you add the top numbers and the bottom stays the same. Yeah.
That's a lot of pizza.
A lot of pizza.
It's right there. That's yours.
I would rather have
Okay, we're gonna try B. What number can you see? If we're looking at B, to be able to add or subtract fractions, you have to have a common denominator. That means same bottom number, right? Currently, you have 3 and 4. To figure out what you want those numbers to become, you count by 3s and 4s. So, for instance, 3, 6, 9, 12. If you count by 4s, it's 4, 8, 12. And you want to find the first one that they both could become. In this case, they both could become 12. So your lowest common denominator would be 12. The first fraction, if I want to turn it into 12, 3 times what would become 12? Yeah, 3 times 4. If you're not sure, it's however many times you had to count by 3 to get to 12. And so if I'm looking at my blue column, it was 4 numbers in. That's why I times it by 4. You do that to the top and bottom. The second one would multiply by 3, top and bottom. This gives you 2 new fractions. It gives you 8 over 12 plus 9 over 12. The tops can then add, so I have 8 plus 9, and the 12 stays as a 12. This is the same thing as saying 8 twelfths plus 9 twelfths becomes 17 twelfths. Probably mostly going to become improper fractions. And that's fine. We'll leave our answers as improper fractions. Unless it ever asks you to write as a mixed, leave it as improper.
Do you ever reduce the improper fraction to its lowest?
Yeah, so for instance, if we had 17 over 12 and those could both divide by 2, then I would divide both by 2. Yeah. Yeah. 18 over 12 could both divide by something, so you do that. In that case, 6. Awesome. Looking at C. My spacing's a little off just because of my formatting. I want to figure out the lowest common denominator. Now, I understand that you might have learned a trick that you just multiply by whatever the other bottom is. Okay, but that's going to probably cause you a little bit of chaos, especially later on in math. It's more ideal to find the lowest common denominator. The lowest common denominator is if you counted by 6 and you counted by 8, what's the first number they both could become? In this case, 24. That's a much lower common denominator than 48, which is what a lot of people get if they're just multiplying by whatever the bottom is. So try your best to always get your lowest common denominator. In this case, it's 24. So I would multiply this first guy by 4 and the second one by 3. That gives me 20 over 24 plus 15 over 24, giving me a total of 35 over 24. That's the ideal way to solve it. I didn't, but I was scared I did.
36?
35. Sorry.
Imagine like just having
Yeah, Jake.
On my page, I don't have a D.
You have D? I think it's in the column next to you. My formatting is just off. Right there.
Is it okay to turn it into a mixed fraction?
You could. Our answers will almost always be improper, but you might have to convert it. Yeah. If you did, no big deal. So if you had 1 and then 11 over 24, that's fine. Yeah. Okay, D. If you look at your denominators for D and you want to make them the same, the lowest number they both could become is 8. The first one doesn't need to be multiplied by anything. The second one just needs to be multiplied by 2. That would give me 7 over 8 minus 6 over 8, which equals 1 over 8. You could get a different denominator, but it's ideal to get the lowest one. Makes your life a little easier.
Would you plus it?
We're subtracting this time. So it's 7 minus 6. Awesome. We're going to do these two quick. Yeah, 35. These two we're going to do a little quicker, just so you can write it in your notes. I would multiply this guy by 4, top and bottom. This guy by 5, top and bottom. That would become 16 over 20 minus 5 over 20. 16 minus 5 is 11 over 20. Yep. So if you look at F, the lowest they could both become is 18. So if I multiplied the first one by 2, that would give me 14 over 18. And if I multiplied the second guy by 3, that would give me 15 over 18. And we're subtracting those numbers. If you were to do 14 minus 15, it's actually negative 1 on the top now, but it's still 18 on the bottom. And you can have negative fractions. So that'd be negative 1/18. We always get positive. Yeah. Thursday. Awesome. Adding and subtracting is the hardest thing to do with fractions, in all honesty. We're going to do multiplying and dividing. Both are super easy. Adding and subtracting is the hard one because you have to get the common denominators, right? So try to get comfortable with figuring out skip counting and figure out which number's the lowest. The more you do it, the better you'll get. Like you'll get really well at it. You just got to practice. Multiplying fractions. Multiplying fractions is super easy. So the beauty of multiplying fractions is you can multiply with whatever denominators, whatever numerators you want. Looking at this question, before we go to multiply, I notice it might help if I simplify first. So looking at 2 over 4, I could reduce that or simplify that by dividing the top and the bottom both by 2, turning it into 1 over 2. The second fraction could also reduce. Both those numbers can divide again by 2, making it 9 on the top and 11 on the bottom. If you can simplify at the start of a question, do it. It'll make your life easy.
Can I simplify just a single fraction in the equation?
Yep. Here's the beauty of multiplication. You just need to multiply the top numbers together, multiply the bottom numbers together. It's that simple. So looking at this, this becomes 1 times 9 on the top, 2 times 11 on the bottom. That turns into 9 over 22. I almost said 18. I was doing 2. Yeah.
Let's say you're counting 2 fractions, and one fraction can simplify, but the other can't. Then you keep the one that can simplify where it is.
Good question. So he's saying, what if you can only simplify one of the fractions? Like in that example, we simplified all 4 numbers by 2. Right? The next example, this one, the first one, it can't simplify. There's nothing that divides into 25 and divides into 9. So that stays as 9 over 25. However, Jake has noticed that the second one can reduce. Both those numbers can divide by 2. They also can both divide by 3. They also can both divide by 6, right? So try to find the biggest number that divides into something. In this case, they both divide by 6, becoming 1 over 3.
Would it be the same answer?
Yeah, your value would be the same, and then you would have to reduce your answer. Because remember, we want to write in reduced form. So Jake's question is, can you do it to just one fraction? Absolutely, you can do just one fraction. And then you can multiply across the top 9 times 1 is 9. Multiply across the bottom, we get 75.
Wait, so if all four can be like the top one, if all four can be like simplified,
Yep.
does it have to be like by the same number, like by 2
No.
or by 6?
No.
It can be,
Each fraction could be its own thing.
yeah.
Even if you reduce properly, and even if you simplify properly at the start of a question, you might end up with an answer that still needs to be simplified. So if you look at this question right now, 9 and 75 can actually both divide by 3. So this one simplifies to be 3 over 25. Like that. So even though we simplified at the start, we still had to do it later on.
Can you just not simplify at the start and then just simplify it all at the end?
Yeah, so for instance, I might need a calculator for this one. No, good, I got one. If you didn't, so he's saying, can you just do it right at the start? You could. 9 times 6 is 54. 25 times 18 is 450. That's a way harder thing to simplify because those numbers are so large, right? But you could do it. They both divide by 18. So if you were to divide both of them by 18, you get 3 over 25. So you do get the same answer, but your simplification is way harder. Yeah. Anytime you can avoid big numbers, I think the better. Especially
faster.
Yeah, I mean, but if you could find 18, like 18 is a hard number to find. That's the hard part. How did I know it? I knew it because I knew the answer. I knew the answer was going to end as a 3. So I was asking myself, what times 3 would get 54? That's how I figured it out. All right. Last 2. Try both of them on your own. So see if you can multiply them together and see if you can simplify them to be the lowest answer once you've multiplied them together. Okay, so C and D can both be reduced or simplified before you multiply them together. C would reduce to be 4 over 9 and 12 over 13. If you multiply across the top, that gives you 48. Multiply across the bottom, that gives you 117. For D, everything can divide by 3 in both fractions. That gives me 9 over 8 and 4 over 15, giving me 36 over 120 when I multiply. However, 36 and 120 can both divide and simplify it a little bit lower. I actually didn't do it right at the start. I divided both by 6. So I looked at those and was like, hey, those both divide by 6. And that gave me an answer of 6 over 20. And then I realized 6 and 20 can both divide by 2, which gave me 3 over 10. So if you don't immediately recognize that both things are divisible by 12, that's fine. But just understand that you should be checking to see if you can divide either of those as well. Awesome. In math, for a lot of what we do, you can do something called verifying your answer, checking to see if you're right. Okay, and so for your assignment, that's probably ideal so that you know if you're doing it right or wrong. The way you do that for this is you're going to take your original question and you're going to turn it into decimals. So I took that red fraction, 27 over 24, and I put it in my calculator. I'm just going to erase this so I can highlight it a little better. I put 27 over 34 in my calculator, and I got 1.125. I then put 12 over 45 in my calculator, and I got 0.26 repeated. If you multiply those two decimals together, you get 0.3. That means that your answer should also equal 0.3 when you're done. So I then went to my answer, which is 3 over 10, and I put 3 divided by 10 in my calculator, and I noticed that both answers were the same, right? They were both 0.3. That means I did it correctly. They should always be the same. We're not changing the value of our questions. We're changing the format and the way they're written. Right? We're reducing them into a nice little fraction that's small numbers. But it's still the same value if you were to do decimals. Okay. Last one, dividing fractions. They have some nice little instructions there, but I learned dividing fractions from someone in like grade 6, and it stuck with me forever. So when you divide a fraction, you are going to do something called kiss and flip. And that's the phrase I will always use. So if I have a fraction divided by a fraction, I say something called kiss and flip. What that means is that you're going to go to your question like this. You have a fraction divided by a fraction. You are going to kiss it, meaning you turn the division into a multiplication. And then you're going to flip the second fraction so that this becomes 3 over 4 times 6 over 5. And to us, multiplication's easy. Multiply across the top, multiply across the bottom. So division questions, if you kiss and flip, makes it nice and easy for you. 3 times 6 over 4 times 5, making it 18 over 20. Again, if you could reduce, definitely reduce. This is 9 over 10. It's called kiss and flip. That's for when you're dividing fractions. For the longest time, I didn't know why it was called kiss and flip. I just always called it that. And then I realized that it's because X means kiss in like X's nose. And like XOXO Gossip Girl. Like the X means kiss, kisses and hugs. That's what's going on. In case you didn't know.
Yeah.
It's a heated debate. It's a heated debate.
X is kids.
B, you have a fraction divided by a fraction. We turn fractions into multiplication by kissing and then flipping the second one. So it's 3 over 8 times 5 over 2. That becomes 3 times 5 divided by 8 times 2. Giving you an answer of, Bree? Boom, 15 over 16. Not right now. In a minute. In a minute, and I'll let you say. Mary. C. C is a fraction divided by a fraction. So we're going to kiss and flip it to look like that. You always flip the second one. Okay, and that's just the rule of kissing and flipping. So this would become 7 times 4, 28 over 8. And if you look, that can be reduced, right? So always check to see if you can divide your answers. Both of those things divide by 4. So that would become 7 over 2. If you look at D, kissing and flipping becomes that. That would simplify to become 40 over 5. 40 and 5 can divide. That would become 8 over 1, which we would just write as 8. Both of them divide by 5. Awesome. Okay, these guys. This is one that usually throws people off because they don't realize it's a fraction, right? That is 2 over 3 divided by a fraction. It's just we don't typically write divide by 1. So when you see a whole number, turn it into a fraction, then you can kiss and flip to become 2 over 3 times 1 over 4. Realize that every number is a fraction. If there's no bottom, it's always 1. This thing would become 2 over 12. It's the same thing as saying 1 over 6.
If you erase part of your answers, you erase the bottom of the
Sure. F. And then I'm going to show you a trick to do some reducing. So if you looked at f, that's the same thing as saying 6 over 1. That means I have 6 over 1 times 5 over 3. That's the same thing as saying 30 over 3. That's the same thing as saying 10. For sure.